In our last math lesson, we learned about the metric unit for length, how to use the metric system to measure length. We talked about meters, decimeters, centimeters, and kilometers or kilometers. Today, our learning goal will be to understand and convert metric units of liquid volume and mass. Now, liquid volume, another word for that would be capacity. Because liquid isn't a solid form, it tends to spread out. So we have to keep liquids contained in some sort of a container. So we want to figure out the volume inside that container. Another word for that is capacity. What is the capacity of that container? How much can it hold? And then we're going to talk about how to measure metric units of mass. Now, mass and weight will be interchangeable today in math class. In science, mass and weight are slightly different, and we'll talk about that in science class. But for today, when you think of the word mass, we're thinking about weight. How much does something weigh? So we're measuring liquid volume and weight today. You'll then use your learning to solve real-world word problems involving liquid volume and mass. So let's get started by looking at our chart. So this is the liquid volume chart that you use to measure metrically. Everything in liquid is measured in liters. Everything in length was measured in meters. Now we're measuring in liters. Remember, it's liquid volume, so it's liquid containers. So 1 liter is everything we use. That's our standard. That's right there in the middle, a liter. We base everything that we use on a liter. And it's going to look very similar to our meters because we had decimeters, now we have deciliters. Then we had centimeters, now we have centiliters, and we had millimeters, now we have milliliters. Same thing on the side for bigger than a liter. We did decaliter or decameters, now we're doing decaliters. We did hectometers, now we're measuring hectoliters, and kiloliters. We did kilometers. So again, everything's based on 10. Metric system is a measurement of 10. This is 10 times smaller, which is then this one is 10 times smaller than this one, and this one is 10 times smaller than this one, and 10 times smaller than this one, which is that one. So everything is by tens, okay, either way that you go from a liter. All right, here is our chart. Here are our first two questions. Mrs. Lee cut out a 2-liter plastic bottle in half to make a 1-liter container. So think of a 2-liter bottle of soda. Okay, she cut it in half. This makes a 1-liter container right here. She marked it on the outside to show equal parts. So, how many milliliters of water will fit into this container? This is a 1-liter container, so here's our 1 liter. How many milliliters fit inside this 1 liter? How many milliliters? It's right here. How many milliliters equal that 1 liter? 1,000 milliliters are what fits inside this 1-liter container. So we use our chart to convert from liters to milliliters. Let's try it again, and only this time we're going to go bigger than a liter. How many of these plastic containers right here will fill a kiloliter container? So I want to fill this kiloliter container out here. And it takes 1,000 liters to fill a kiloliter. It takes 1,000 of these to fill a kiloliter. So how many of these plastic containers will fill a kiloliter? 1,000. Because a kiloliter is 1,000 times bigger than a liter. This one is 10 times bigger. This is 100 times bigger. This is 1,000 times bigger. This is 10 times smaller. This is 100 times smaller, and this is 1,000 times smaller. So the metric system, again, is all based on that 10, 100, 1,000. Let's think back to converting those metric units for length. And we got to remember which operations we're using to convert those metric units. Are there any tips or hints that you know you are converting correctly? So how is the chart for length similar to the chart you use to convert metric units of volume, and how's it different? Well, we're going to compare 3 different charts by the end of this lesson. So let's keep thinking about that. All right, here's our chart again. Let's see if we can answer these. I'll give you a minute to figure this out. How many milliliters are equal to 3 liters? Well, here's 1 liter. Now imagine this is 3 liters. How many milliliters are there in 3 liters? There's 1,000 milliliters in 1. So how many milliliters are in 3 liters? And that would be 3,000 milliliters, because 1,000 milliliters in 1, 2,000 milliliters in 2, 3,000 milliliters in 3 liters. Now, think about this one. How many milliliters are equal to 35 of these? If there's 1,000 in each liter, how many milliliters are in 35 liters? 1 liter is 1,000 milliliters. 2 liters is 2,000. 3 liters is 3,000. How many milliliters are equal to 35? Well, for every liter there's 1,000, and I have 35. 35 times 1,000, 35,000. That's how you convert that. Let's go on. How about this one? Every morning for breakfast, Micah, I think it's Micah, drinks 20 centiliters of orange juice. How many milliliters of orange juice does she drink every day? She drinks 20 centiliters of orange juice. So this is 20 centiliters here. How many milliliters would that be? Remember, everything is 10 times 10. Divide by 10 more, divide by 10 more, or think of it as multiplication. So we're using the operations of multiplication and division. So I have 20 centiliters. How many milliliters is that? 20 centiliters. In every every centiliter, there are 10 milliliters. So 20 centiliters times 10 would be 200 milliliters are in that orange juice. So think about it. If the number 20 is written right here, there's 20 centiliters. How many milliliters is that? Well, since this is 10 times smaller than this, I'm multiplying this 20 times 10 and getting 200. How about mass, weight? Chart looks very familiar, doesn't it? Now, when we measure something in weight, we use the word grams. In the metric system, we use grams. In our system, we use pounds and ounces. But in the metric system, it's measured in grams. So, same setup again. Look, here's the unit of measure, a gram. 10 times smaller is a decigram. 10 times smaller than that is a centigram. 10 times smaller than that is a milligram. Deci, centa, milli. Same as the length, same as the liter. Grams, bigger than a gram. 10 times bigger than a gram is a decagram. 100 times bigger than a gram is a hectogram. And 1,000 times bigger than a gram is a kilogram. So, let's see if we can answer these questions. How many grams are in 40 kilograms? How many grams are in 40 kilograms? Well, there's 1,000 grams in 1, and I have 40. There's 1,000 grams in 1 kilogram, and I have 40 kilograms. So 40 kilograms times 1,000 will tell me how many grams are in there. 40,000 grams are in 40 kilograms. 40, if I put the number 40 here, 40 kilograms. Each kilogram is 1,000 grams. If I have 40 of them, that's 40 times 1,000. That is 40,000. Oh, how many grams are in 5,000 kilograms? How many of these? 1 gram. Okay, there are 1,000 of those in 1 kilogram. I have 5,000 kilograms. 5,000 times 1,000. 5,000 times 1,000. Can anybody do that in their head? Think back to our multiplication unit. 5,000 times 1,000 will give you, giving you a minute to figure it out. Do you know the answer is 5 million grams? That there are 5 million grams in 5,000 kilograms. All right, let's try this one. Angie's puppy weighed 3 kilograms. We're out here, 3 kilograms when she first got it. 2 years later, it now weighed 9 kilograms. Okay, so now it's 9 kilograms out here. So how many grams is that? 9 kilograms. Remember, 1 kilogram is 1,000. 9 kilograms is 9,000. Okay? So now the question is, how many grams did the puppy gain? So the puppy started at 3 kilograms. It's now 9 kilograms. So it's increased by 6 kilograms, which is 6,000 grams. And that's how you convert that problem. So, let's take a look at some things I have in my kitchen. How about an iced tea? Let's get the idea for liquid first, for our liters. When we measure in America, we do it by, see this, 16.9 fluid ounces? Well, that's about 1.05 pints. Here's the metric measure right here, 500 milliliters. 1,000 milliliters equals 1 milliliter. I have 500, so I have half of a liter here. So drinking one of these is like drinking a half liter of liquid. And that's one of those servings that you can buy in a grocery store or a convenience store. This is half of a liter. Let's look at another liquid measure. How about one of these mini cans of Schweppes ginger ale? Zoom in so you can see the liquid volume of it. Okay, it is 7.5 fluid ounces. Here's our metric down below it. 221 milliliters. It takes 1,000 milliliters to make 1 liter. I only have 221 milliliters. So that's a lot less than that. Remember, this is a half of a liter. This is only 221 milliliters. So liquid measure using either the word capacity or volume. Now, let's talk about grams, weight. Some things in your kitchen that are measured by weight because they're not liquid would be something like this, some Philadelphia cream cheese. So I was looking for the weights on this one, and I see it right here. Okay. Now again, they give it to us in ounces first because that's what America's used to, ounces. But in the metric system, it's 226 grams. Remember that gram, 1 gram is the unit we use. This is bigger than a gram. This is 226 grams, okay, in this container. But this is not a liquid. This is a solid. Believe it or not, ketchup is not a liquid either. Okay, when we look at this, we're measuring in 20 ounces. In the metric system, it is 567 grams. 567 grams in this container of ketchup. So, let's look at our next chart. Here is what we've learned. Units of length, units of liquid, units of mass. The charts all look the same. We use a meter for length, a liter for liquid, and a gram for weight. And then either side of those measures are exactly the same types of